So day 26 lesson is on dimensioning. So from your workbook, get dimension 1, dim 1, dim 2, dim 3, and the file names or the file numbers are 58 for dim 1, 59 for dim 2, and 60 for dim 3. They're all due Friday, November 18 by 7 p.m. in order for you to be considered present for this asynchronous class. And then there is a lecture material here, which is dimensioning. So I'm going to review this with you today. And you should look into this again on your own. Okay, so dimensioning. So here are some things that you need to know. There is an extension line. There are two types of lines. One is the extension line. The extension line are these lines that come out or projects out of the edges. So this is an extension line. This is another extension line. Here's another extension line, and you got another extension line right here. And then the other line that we're using for dimensioning are called dimension lines, and dimension lines start or terminate with an arrow. So there's an arrow right here, and then there's another arrowhead right here. So these are dimension lines. And then a third type of line would be a leader line, and a leader line is just a dimension line for circles and for arcs. Okay, and then here are some rules for dimensioning. It says here the dimension line should be approximately 3/8 from the object. So what they're saying is that this line should be about 3/8 away from the object. Okay, and we're going to just approximate this. We're not really going to measure it with a ruler. And then the letters are 1/8 of an inch height. And then also the arrowheads are 1/8 of an inch long. Okay, the heads. And then also there is a gap, which is 1/8 of an inch again, gap between the edge and the extension line. So this slide right here talks about all of these rules, and we're going to practice this in a bit. Some notation errors. If you have a leading 0 on a number like 0.75, so the common practice is not to write the 0 in front. So the right way of writing this would be 0.75. And then in inches, you don't have to write the quotation marks. Okay, so no need to write quotation marks, no need to write the letters IN or inch. And then for millimeters, same thing, omit mm, which is millimeters, and then omit any trailing zeros with millimeters. So instead of putting 24.00, it just says 24. And that's how you differentiate millimeters from inches. But also normally in blueprints, they would say if it's in inches or if it's in millimeters. But you just need to know that you shouldn't be writing any units. And then continuous dimensioning is what we're doing. It starts on one edge of an object and continues across the object. And here's an example. So if you look, follow my arrow, there are 4 edges here. There's 1, 2, 3, 4. And with 4 edges, you need to subtract it by 1. Any number of edges, subtract it by 1. That's how many dimensions you should put. So the first dimension, for example, from the first edge to the second edge is 12 inches or 12 millimeters, whatever this is. And then from the next one, from the second edge to the third edge is 15, whatever the unit is. And as you can see, the last one shouldn't be put this way. The last one should be it should be the total dimension of the object, which is the total length of the object. So from the first edge to the fourth edge, there should be a line that goes up here and then up here, and then there should be a dimension, and the dimension would be the total dimension, which is 12 plus 15 plus 9. Okay, and then if we look at the right side of this front view, you could actually see this one is 12, and then they dimensioned from the edge, from the top edge to the edge below it is 6, and then the 6 in between shouldn't be used at all. Instead, there should be a total dimension for the height of this object. Okay, so it says here, omit or erase one dimension in a series, since the overall dimension will provide the missing measurement. All right, so the next slide talks about visibility of features. You normally dimension where you can see the shape of the object. So given the top view, and you could see the edges of the top view, but in the front view, you could actually see the contour. Okay, you could see the shape of the object, and that's where you should be dimensioning 12 and 9 instead of dimensioning it here at the top view. So 12, 9, and then what is the total dimension of this? That's the third dimension you have to add. Same thing with the height. You have 12, and then you have 6, and then there should be another dimension here saying what the total height is. Okay, hidden lines. Never dimension to a hidden line. So this shouldn't be done at all, where you have a hidden line right here, and then you have a dimension. So that's a common error. Instead, you look at the drawing, and if you look at the front view actually shows that this is a better place for you to dimension it. And then for angles, this is how you would measure angles. Or sometimes in 3D models, you just need to have the dimension of the, from the left edge to the rightmost edge. And if you have that same thing from the bottom edge to the top edge, you will actually get the angle. Okay, but in this case, if you just want the angle, this is how you do it. And then next, size dimension. In order to logically place dimensions, approach the object with the intent of dimensioning in the order of size, which means try to dimension the smallest part first before you go with the overall dimension. Okay, so here's a part 12, 15. After I'm done that, I'm going to do an overall dimension of the entire thing, which is the largest dimension, and so that would be on the outermost level of dimensions. Okay, linear dimension placement. Here are different ways of dimensioning. 12, as you can see here. I mean, the third example is the most common because you could fit in the number 12 or whatever number in such a large space. But if you can't put the number and the arrow, another way of writing dimension would be here on the second example, where you have the number inside and then you have 2 arrows on the outside pointing inward. That means you're measuring inside. Still, another example is if it's really small and narrow on the inside and you cannot write the number, you could do 2 arrows and put the number to your right, to the right of the arrow, of the right arrow. And then still, a fourth example is when you have multiple dimensions, one chained after the other, and you need to dimension all of them, but there's not a lot of space. You could do this thing that you see right here. Arc dimensions. So for arc dimensions, there are 4 ways of doing it also. The most common way is doing the first example. So you have a leader line, and instead of the diameter symbol, you put the letter R for radius and then the value of the radius. So this is how you dimension arcs, since it's not a complete circle, so you cannot use diameter as the measuring unit for it, and then, or as the measurement for it. And then for This example, it's the same as the first one, except that it's large enough to put the center mark. And then if you have enough space for the arrow, you could actually have the arrow coming off of the center mark and then out with the arrowhead inside the arc. And then you have the extension of the leader line going outside. And still, if you have plenty of space, you could do number 4. Okay, example number 4. All right, how about holes? Holes are represented by a circle, and the hole is dimensioned where it appears round or circular. So as you can see in this example, the hole is inside. So where it's a hole, that's where you need to put your leader line, touching the circle and then going out of the object and then putting the diameter symbol and the diameter. Okay, so never do this, because this one breaks 2 rules. Again, the first rule is the rules of holes, where you have to dimension where you see it as a circle. And the second rule that it breaks is do not dimension on hidden lines. Okay, next, cylinders. If you have a cylinder and one of the views shows as rectangular, that rectangular view is the one that you have to dimension. So instead of dimensioning 12 for the circle, the diameter of 12 for the circle, you'll write diameter and then the number that goes right here. So I don't know why this is 12. If this is, the diameter is 12. I mean, if the diameter, it looks like the radius is 12, but the diameter is 24. So this should have been 24. Okay, but the height of the rectangle, which is actually a circle, is just the diameter. Okay, so diameter of 24. I guess I'm going to end it right here, and then you all can watch my next videos, which shows you examples on how to dimension.